Assalamu alaikum warahmatullah. Dear students, today we are going to start Newton's second law of motion. First of all, let us see the statement of this law. What this law states. Let me write down the statement of this law. According to this law, it states that the rate of change of momentum of a body is always equal to the external unbalanced force. So this law says when we apply the force on an object, it changes the momentum. So the rate at which the momentum gets changed, it is proportional to the force, external force which is applied on the body. Now let us derive this law. Find out the measurement of this force. Newton's second law gives the measurement of the force. And let us try to get the measurement of the force from the derivation. Consider an object. Let us suppose this object is moving with some velocity, let it be u, having mass m. After t time, it is being acted upon by external force, so its velocity gets changed. So its velocity gets changed, it will move now with v velocity. So when it was moving with initial velocity u, therefore it possesses momentum, because we know when the body is in motion, it has a momentum. So let us calculate first the initial momentum. Let's calculate the initial momentum. It is always equal to mass into initial velocity of the body with which the body is initially moving. After the application of the external force which is acting on this object, the velocity of the object gets changed. So we can calculate here the final momentum. So that will be equal to m into v. So here this arrow represents vector because these are the vector quantities. Now change in momentum can be determined. Change in momentum can be determined, that is equal to final momentum minus initial momentum. So change in momentum we can calculate that is mv, substituting because we have already calculated final momentum, minus mu. So this is change in momentum. M can be taken out because it's common, so it will be v minus u del p. Now using second law status the rate at which the momentum changes, so momentum changes with time, is proportional to the external force which is acting on this object. So we can say F is proportional to del P is mv vector minus u divided by t. So we just eliminate this proportionality, diminish, so we get is equal to k, or keep it as it is, and let us write F proportion m and keep this term as v minus u by t. We know acceleration is equal to v minus u by t. So here we can substitute F is proportional m a vector. It will be F is equal to K M A. A has been found experimentally, test value is equal to 1. Final expression we can get 1 into MA, or F is equal to MA. So this is the expression which we got from the Newton's second law. So Newton's second law gives the measurement of the force, which is equal to mass of the object and its acceleration. Here the mass is, since mass is constant in classical physics, so we can say force is proportional to acceleration. So if we produce more force, so it will produce more acceleration. So this law, the second law, gives the measurement of the calculation of the force. So we can find the force, and we find the force in newtons because the center of force is Newton. So this is Newton's second law. Now let us start Newton's third law. Newton's third law. First of all, let us see the statement of this law. According to this law, it states that to every action there is an equal and opposite reaction. In other words, we can say if a body A exerts a force on body B, then body B exerts the same magnitude of force on body A, but in the opposite direction. For example, this is objective. Let us suppose these two objects collide. When there occurs collision, this exerts force, this body A, this body B. So collision, during collision, this body has collided with the body B. So force is exerted by A on B. Now, as per the Newton's third law, there will be the reaction, but reaction will be of the same magnitude but in the opposite direction. It will be F B A. So Newton's third law we can represent like this: mod of F A B is equal to minus F B A. Negative shows that these two forces are equal in magnitude but opposed in direction. So these are also called as action-reaction forces. They must act on different bodies. So in this way we have discussed two laws, Newton's second law and third law.